we have the 3 different switching modes listed right here. Process switching, fast switching, Cisco Express forwarding. What is on by default? What is the best switching method? Cisco Express forwarding. That's what we want our routers to use. But let's not start our discussion right there. Let's go all the way back to the very first switching method that was ever invented. And what our routers essentially default to when we turn on debugging. For example, if you turn on debug IP packet, our router is doing process switching. And what does process switching mean? It means that every single packet is examined by the CPU. Where is the CPU? It's in the control plane. That's where the CPU is. So what does that mean for a packet that arrives inbound on gigabit 0/0 if we're using process switching? The data plane needs to find out where to send this packet to. What is the exit interface? Up it goes to the routing table. The routing table in the control plane, utilizing the CPU, is going to determine now how we forward this packet. Once it determines that the exit interface is gigabit Ethernet 1/0, right down here for this packet. Based on what? The destination IP address in the packet. It now needs to identify the MAC address of the next hop IP address. So what happens? Let's consult the ARP cache. Again, in the control plane, utilizing the CPU. So decisions are being made in software, not hardware, in software it's referred to as. And therefore, it is what? Slow. Slow. It's the slowest method we have. And then once all the information is determined, it now goes back down to the data plane and gets sent out that egress interface. That's process switching. What about fast switching? Fast switching is also known as route caching. Why? Because we cache information. What type of information? That lookup that we did as to what is the egress interface for this packet, what is the next hop IP address's MAC address. We store that down here in the route cache. So we have the first packet in a flow that arrives inbound on gigabit 0/0. Now, what is a flow? A flow is a group of packets that are all coming from the same source, going to the same destination, using the same protocols, using the same port numbers, using the same QoS markings, arriving inbound, all on the same interface. So they all belong to this same flow. So here's what happens when the first packet in the flow arrives. The router takes that packet, looks at the destination IP address, examines the routing table in the control plane, and then makes its decision based on that information. And it decides that the exit interface is gigabit Ethernet 1/0. What's the MAC address of the next hop? Let's figure that out in our ARP cache. So we examine the ARP cache. We find out what the MAC address is. We then ship it down to the data plane. And what do? We make an entry in the route cache. So now that there's an entry in the route cache, the rest of the packets in the flow simply do this. So the very first packet is process switched, and every other packet after that is fast switched, or the lookup is done in that route cache as opposed to having to examine the IP routing table in the control plane. Let's examine CEF now, Cisco Express Forwarding. This is the optimal switching method. It's also known as topology-based switching. The data plane. It's all about hardware, folks. There is hardware at the data plane that is extremely fast, and as a result, we don't rely on the software. We don't rely on the CPU to make the forwarding decision. So instead of asking the control plane, what do I do with this packet? The information stored in hardware down at the data plane instead. And it's stored in what is known as a FIB, a forwarding information base, and an adjacency table. What is the FIB? It is a hardware version of our IP routing table. What is the adjacency table? It's a hardware version of our ARP cache. So what happens now? Well, we create the FIB and the adjacency table ahead of time. That's what the router does. Ahead of time. That way there, the information's at the data plane. A packet arrives inbound. Do we have to consult the control plane? Do we have to make decisions in software? No. We make all the decisions in hardware. Based on the destination IP address, where do we have to send this particular packet? We have to send it out gigabit Ethernet 1/0. All right. How do I get to the next top IP address that is listed in the FIB? It tells me in the adjacency table. Use this MAC address for the frame. Rebuild the frame. Out it goes. At no point in time do we have to consult the control plane unless information is missing. For example, if information is missing in the adjacency table, we're missing a MAC address. Well, at that point in time, since there's no information in the adjacency table, we'll have a little detour, and the detour will be to figure out what's going on. Is it in the ARP cache? No, let's do a quick ARP. Let's find out what the next top MAC address is, populate the ARP cache, put that in the adjacency table, so that way there, all the subsequent packets are just going to come in the interface, go through the FIB, go through the adjacency table, and go out the interface.